morning, students. Welcome back to my YouTube channel, and today we are going to look at carbon chemistry, and our today's lesson is lesson 5 because we previously looked at lesson 4 the other week. And if you are new to this YouTube channel of Study Online Uganda, kindly click on subscribe button so that you can follow all our lessons that we always upload, so that you can continue learning with this Study Online Uganda. So now, today, as I've told you, we are looking at carbon chemistry, and under carbon chemistry, if you recall from our previous lesson, we were looking for how carbon dioxide can be tested in the laboratory, and now today we're going to look at the properties of carbon dioxide gas. So under properties, we shall have the physical properties and the chemical properties. So we are starting with physical properties. So the first one is that it is colorless and has no smell. So carbon dioxide gas is colorless and it has no smell. And also it extinguishes a burning splint. When you bring a burning splint near a gas jar containing carbon dioxide gas, it will immediately go off because carbon dioxide does not support burning. And it is also denser than air, and therefore it is collected by downward delivery method. This one you must have looked at it in senior 2 when you are looking at the collection of gases. So it is denser than air, and that is why it is collected by downward delivery. Remember that all gases which are denser than air, they are the ones which are collected by downward delivery method. And also it turns wet blue litmus paper red. So this is how we test the presence of carbon dioxide in the laboratory. We test it by getting a blue litmus paper. We first put it in water so that it can become wet, and then from there, when carbon dioxide gas is passed over that wet blue litmus paper, it turns to red, as we shall be seeing in our chemistry practical. And lastly, it does not burn and does not support combustion. So it doesn't burn, neither does it support combustion. So those are some of the physical properties of carbon dioxide gas. So now let us see the chemical properties. How does carbon dioxide behave chemically? How, when it reacts with different elements, what happens? What are the products? That is what we call the chemical properties. And the first one, under the chemical properties, it states that carbon dioxide is slightly soluble in water, forming a weak carbonic acid. So carbon dioxide is not purely soluble in water, but it is slightly soluble, and when it dissolves in water, it forms a weak carbonic acid. And the equation, you can see it, it is carbon dioxide gas reacting with water, and it is forming a weak carbonic acid. So because this acid that is being formed is weak, that is why these reactions are called irreversible reactions. You can see there is a line like this and another one like this. So those two lines, they indicate that the equation is irreversible. So when carbon dioxide reacts with water, it forms a weak carbonic acid. So from here we come to learn that the rainwater, because rain, when it is falling, it is water that comes, then it reacts with carbon dioxide in the atmosphere, forming carbonic acid. So the rainwater which we always collect is not water, instead it is a weak carbonic acid. So and the reaction is irreversible. The reaction is reversible. It means that this carbonic acid can again break down into carbon dioxide and water. So that is the first chemical property of carbon dioxide gas, is that it reacts in water, forming a weak carbonic acid. So now we have another property of carbon dioxide gas. As you can see from the equation, that one is calcium hydroxide plus carbon dioxide gas, and we are forming calcium carbonate and water. So this property of carbon dioxide is that carbon dioxide, it turns lime water milky due to formation of calcium carbonate. So carbon dioxide turns lime water milky. Lime water is the one which we call calcium hydroxide. So when calcium hydroxide reacts with carbon dioxide, it forms calcium carbonate and water, and the calcium carbonate is insoluble. That's why it is a solid and water is a liquid. So they can ask you a question, for example, that state what is observed when carbon dioxide gas is passed through lime water. So the observation is that the lime water turns milky, as we shall come to see in our examples of examination questions. So that is the second property of carbon dioxide gas. Then we also have a note that if carbon dioxide gas is passed through calcium hydroxide for a long time, the lime water turns milky and later becomes colorless due to formation of a soluble calcium hydrogen carbonate. So now, carbon dioxide gas, if it is passed through lime water, which is the calcium hydroxide, for so long, for a long time, there it first forms a white precipitate, as you have seen, of calcium carbonate, and later it forms a soluble solution of calcium hydrogen carbonate. So here, the equations, they will be as follows. We shall first have calcium hydroxide reacting with carbon dioxide gas to form calcium carbonate and water, just as we have seen. Then from there, if it is in excess, the carbon dioxide gas will go on to react with calcium carbonate and water. So it will react with those products formed above. Then we add in more carbon dioxide gas to form calcium hydrogen carbonate, which is a colorless solution. So if you are asked the question that the carbon dioxide gas was passed through lime water for a long time, the observation will be the formation of a white precipitate, which we call a milky, and later a colorless solution. As we shall see in the examples, we shall come to understand. And here, if they say that you write the equations, you write two equations because there are two processes that are taking place. So now, having looked at that property, let us look at the third property of carbon dioxide gas. It says that reaction of carbon dioxide with alkalis. So now, carbon dioxide also reacts with different alkalis, and it is more soluble than in water. So it is soluble in water than, it is soluble in alkalis than in water. How? Take an example of sodium hydroxide. When carbon dioxide gas reacts with carbon dioxide gas, it forms sodium carbonate, which is a colorless solution. From this equation, as you can see, we have sodium hydroxide reacting with carbon dioxide gas. It is forming sodium carbonate and water. So the sodium carbonate is a colorless solution. And now, let us come to see this note. If excess carbon dioxide gas is passed through the alkali, a white precipitate of sodium hydrogen carbonate is formed. So we have seen that sodium hydroxide, when it reacts with carbon dioxide gas, it forms sodium carbonate, and this sodium carbonate is a colorless solution. But if the carbon dioxide gas is in excess, it means that the sodium, as we can see from this equation here we are forming sodium carbonate, which is a colorless solution, and on this next equation, so the sodium carbonate will react with the water and the carbon dioxide gas. So the product from above will come and then react with more carbon dioxide because it is in excess, and it is forming sodium hydrogen carbonate, which is a white precipitate. So it means what? It means that in case you are asked a question, and the question is requiring you to state what is observed when carbon dioxide gas was passed through sodium hydroxide for a long time, we have to state it clearly that a colorless solution is formed and later a white precipitate is formed, as we shall come to see in our questions of different examinations. So now we have so far looked at sodium hydroxide. Let us come to potassium hydroxide, because we are looking at alkalis reacting with carbon dioxide gas. So now potassium hydroxide, it reacts with carbon dioxide gas to form potassium carbonate solution, which is colorless, but in excess it forms a white precipitate of potassium hydrogen carbonate. So you should take note of this. So on the equations, we shall also have potassium hydroxide reacting with carbon dioxide gas, forming potassium carbonate and water, and therefore we shall have another equation of the products in the above reaction reacting with more carbon dioxide to form a white precipitate. That is where we have potassium carbonate plus water plus carbon dioxide gas forming potassium hydrogen carbonate. And remember to balance your equations. Your equations must be balanced all the time. So for now we have looked at the reaction of carbon dioxide with the alkalis. So please, if you are new to this YouTube channel, click on subscribe so that you can follow us and follow our videos. But we are continuing. Now, having looked at that reaction with alkalis, we are going to look at some sample examination questions. How different examinations are set, because it is important for us to revise and see whether what we are learning, if we are able to answer them. So now that's why I prepared the sample examination questions, and here we have number 1, and it is saying that carbon dioxide gas was passed through lime water for a long time. So now the first question is saying state what was observed. So carbon dioxide is being passed through lime water for a long time, and here the observation which we said is that the lime water, it turns milky and later it becomes colorless solution, as we have already seen in today's lesson. And now we have part B. They are saying that we write the equations for the reaction. So if they say equations, those are two equations. So you have to write two equations. The first one, you have to write calcium hydroxide reacting with carbon dioxide gas to form calcium carbonate and water. Then you balance the equation. After balancing that equation, you come down and then write another equation of calcium carbonate plus water plus carbon dioxide gas forming calcium hydrogen carbonate, which is aqueous. So remember to also indicate these states: aqueous, solid, liquid, and remember to balance, because in chemistry each equation must be balanced for it to be marked. So here we have, that was our question 1. Now here we have the second question. This is the figure that is showing the laboratory setup of two apparatus. As you can see from the diagram, we have test tube A and we also have test tube B. And in test tube A, we are seeing we have zinc carbonate that is down. They are like crystals down there. And we also have dilute hydrochloric acid on top of it. Then in the other test tube, they are connected using a delivery tube. Test tube B contains lime water. So now let us come to look at the questions. The questions are saying, part A, Roman 1, state what is observed in test tube A. So now they want us to state what is observed in test tube A. As we have seen in our test tube A, we have zinc carbonate, which are crystals, and we also have dilute hydrochloric acid. And now they are reacting. What do you observe? From what we studied in our lesson 4, we said that any carbonate, once reacted with an acid, you produce carbon dioxide gas. So now here what will be produced, the answer for the observation, it is the effervescence of a colorless gas that was observed. So there was effervescence of a colorless gas in a test tube A. Then now they want the equation for the reaction in test tube A. The equation, as we have seen, is zinc carbonate and hydrochloric acid, and they are reacting to produce zinc chloride plus carbon dioxide gas plus water. And you remember to balance the equation as we saw in our previous lessons. Now they are also asking that name the gaseous product formed. The other gaseous product formed from the other reaction. As we have seen, it is carbon dioxide gas. And now Roman 2 is saying state what was observed in test tube B. So now if we check back in our test tube B, if we check back here in our test tube B to see what was there, we will come to find out that in our test tube B we had lime water. But remember, the carbon dioxide produced from test tube A is moving through the delivery tube to test tube B. It means we have the carbon dioxide gas from test tube A going to react with lime water in test tube B. So what do you expect to see in test tube B? In test tube B, we shall come to find out that we have carbon dioxide gas reacting with, as we have seen that what was observed in test tube B, and now we are saying that the lime water turned milky, so it turned milky. Then as we go on, we also have another Roman 3 saying write the equations for the reaction in test tube B. Now the equation for the reaction in test tube B is very clear, because we have lime water and carbon dioxide gas, and when they react we have calcium hydroxide plus carbon dioxide gas forming calcium carbonate and water. So that is the equation for the reaction. So now there are very many other questions, because there are very many examination questions. You can contact me via my email there on your screen, then you can request for them and then I send you. And you can also WhatsApp me on that very number that is on the screen if you want more examination questions about this carbon chemistry, because we have them in PDF format and in files. So anytime you want them, you can contact me via those two social media platforms. And please, if it is your first time, subscribe for more videos, and please don't forget to like and also comment. So subscribe for more videos, and thanks for watching.